So welcome guys. Let us discuss the question number 34 from the NCERT. So it says there's a welding gas that contains only carbon and hydrogen. So it's a hydrocarbon. So a small sample of this gas is burnt in excess oxygen and it gives us 3.38 grams of carbon dioxide and 0.690 grams of water and no other products. Okay? A volume of 10 liter at STP. This gas is found weighing 11.6 grams. Okay. So this gas gives only carbon dioxide and water and no other products on combustion. Okay, guys. So we'll use simple stoichiometry over here. So can I say that 1 mole of CO2, 1 mole of CO2, it contains 12 gram of carbon. Okay, guys, which is roughly 1 mole of carbon. Okay. So 1 mole of CO2 contains 1 mole of carbon. So we can say 1 mole of CO2 contains 12 gram of carbon. Okay, guys. So can I say 44 grams of CO2 contains 12 gram of carbon? Okay, guys. So can I say that 1 gram of CO2 contains 12 by 44 gram of carbon? Okay. So in the question it is given to me, we are having 3.38 grams of CO2. Okay, guys. So this will contain 12 by 44 into 3.38 grams of carbon, which is also equal to, so this thing is also equal to, let us calculate, this will be 0.9217 grams. Okay, guys. Similarly, 1 mole of H2O, 1 mole of H2O is having 2 gram of hydrogen. Okay, which is equal to 2 mole of hydrogen atoms. Okay, guys, 2 mole of hydrogen atoms. So similarly here, 18 grams of H2O, 18 grams of H2O is having 2 grams of hydrogen. Okay, guys. So can we say that 0.690 grams of H2O will be having 2 by 18 into 0.690 grams of hydrogen, which will be equal to, if we calculate, this is equal to 0.0767 grams hydrogen. So this many grams of carbon we are having and this many grams of hydrogen we are having. Okay, guys. So since hydrogen and carbon are the only compound in this, okay, guys. So can we simply say that the total mass, okay, guys, the total mass of this compound is 0.9217 grams plus 0.0767 grams, which is equal to 0.9984 grams. Okay, guys, the percentage of carbon in this will be 0.9217, the mass of carbon upon the total weight. Guys, upon the total weight, this is roughly equal to 92.32%. Similarly, percentage of hydrogen in this will be 0.0767 mass of hydrogen upon the mass of compound 0.9984 into 100. So this is equal to 7.68%. So this is the mass percent of hydrogen. This is the mass percent of carbon in this. Okay, guys. So if we calculate the moles of carbon, suppose we are having a 100-gram sample. So in a 100-gram sample, we will have 92.32 grams of carbon divided by the molar mass of carbon, which is 12. So moles of carbon here will be 7.69 moles. Okay. Similarly, if we talk about moles of hydrogen, so these will be equal to 7.68 divided by 1, which is the molar mass. So it will be 7.68 moles. So we can see that, the number of moles of hydrogen and the number of moles of carbon are same. Okay, guys. So the empirical formula will be CH. Okay, guys, since the number of moles of carbon and hydrogen are same, so the empirical formula, which represents the basic fundamental ratio between the carbon and hydrogen here, will be 1:1. So the empirical formula will be CH. Okay, guys. So if we talk about the molar mass of this, okay, in a volume of 10 liters. Okay, guys, the volume of this 10 liters of gas is 11.6 grams. Okay, so let us do this calculation in this space. Okay, guys, so can we say that if 10 liter weighs 11.6 grams, then 22.4 liter will weigh 11.6 divided by 10 into 22.4, because we know this is the mass of 1 mole of gas. Okay, guys, this is the mass of 1 mole of gas. It is Tp. 22.4 liters represents 1 mole. Okay, guys, so this is approximately equal to 25.984 grams, or we can approximate this equal to 26 grams. Okay, guys, now CH, the molar mass of CH is 12 plus 1 equal to 13. Okay, guys, the molar mass of CH is 12 plus 1 equal to 13, but the molecular formula is saying that molar mass should be 26. So can we say that CH is the empirical formula, whereas the molecular formula will be C2H2. Okay, guys, the molecular formula will be C2H2, because CH represents the simple ratio of atoms in the molecule. The ratio is 1:1. So the mass of this CH molecule was 13, whereas the mass of this molecule was 26. So 26 by 13 is a 2. So the actual ratio of atoms, or the actual number of atoms, will be C2H2 in the molecule present. Okay, guys, so this welding gas will be C2H2. Okay, thanks for watching. Stay tuned for more lectures, beta. Okay, thank you.